Kia ora, Year 12. Here's question 3 from the May-June 2018 Stats 2 paper, paper 71. So this question is one where we have to use an approximating distribution to model a Poisson distribution. So here's the problem. We've got the number of e-readers sold in a 10-day period is modeled by this distribution. So Poisson with a mean of 5.1. Use an approximating distribution to figure out the probability that fewer than 140 e-readers are sold in a 300-day period. So the first thing we need to do is to figure out what lambda is for a 300-day period. So we've got lambda is equal to 5.1 for 10 days. So for 300 days, what did we do here? Well, we times that by 30. We times this by 30 and we get lambda is equal to 153. So now we're checking which approximation we can use. And we've got lambda is greater than 15, so we can use a normal approximation. To use a normal distribution, we need two parameters. We need mu and we need the variance. So mu, the mean, is going to be 153 and the variance is also going to be 153, which means that sigma will be root 153. If you're wobbly on this, you need to go into your textbook and head to page 224. Now, the other big thing we've got to remember is that a Poisson distribution is a discrete distribution. So we're looking for the probability of fewer than 140 e-readers. So that means that we want to include, it's not going to work, let me move down. So we want to include 139 e-readers, but we don't want to include 140 e-readers. When we turn to the normal distribution, we're working with a continuous distribution, so we need a continuity correction. So the way we do that is we look at that bar that we want to include of 139, and we say, well, what are the endpoints? Well, the top endpoint is 139.5. So what we're going to find now is the probability that I'm going to call it x bar is less than 139.5. And x bar is my normal approximation. So x bar is roughly normal with mean of 153 and variance of 153. So the probability that x dash is less than 139.5, we now turn into a normal distribution problem, which is this. The probability that z is less than 139.5 minus the mean divided by the standard deviation, which is 153. That gives me the probability that z is less than negative 1.091. Right, at this point it is always worth drawing a wee picture. So we're looking for, that's a terrible picture for that z value. Let's do it again. So here's 0, something more in the tail. So we've got negative 1.091, but we have to use our tables. So we want to convert that into a problem with the table set up how it is. Using symmetry, what we're looking for, here's positive 1.091, is the probability of all of that. So 1 minus all of that. So this is the sign we use for our normal cumulative density function. We have to force it into the pattern we need for the tables. So it's 1 minus all of this. And so the table is going to give me that number, but we don't want that. We want the upper or lower tail. Right, now if I use the tables, and when I did it I got 0.1377, but we need to round that to 3 significant figures, so we get 0.138. So just notice that this number here comes from using the number in the main body of the table plus the little add-on factor down here. In this case I don't think it made any difference, but sometimes it will. So just make sure that you're really confident with how to use your normal distribution tables. All right, that's all for question 3. I'll be back later on with question 4.